Okay, let's dive in. We've got a whole stack of sources here today, articles, research notes, and they're all pointing towards, well, a tech development that hasn't maybe hit the mainstream headlines yet, but it feels like it could be a really big deal.
Hmm.
We're talking batteries, but maybe not the ones you're thinking of. We're talking about salt batteries.
That's right. Often, sodium-ion batteries specifically. The core idea is pretty straightforward, really. Using sodium, from sodium chloride, just plain old salt instead of lithium.
Right, salt. Seems almost too simple.
It does, doesn't it? But our sources really dig into why this seemingly simple swap is, well, suddenly gaining some serious momentum.
And that's our mission today, isn't it? To sort of cut through the hype or maybe the lack of hype and see what these sources actually tell us. Why now? What's the big advantage?
Hmm.
Where are they actually being used? And maybe most intriguingly, how this could connect to some pretty big global dynamics. We want to pull out the key stuff, get you up to speed quickly.
Okay, so starting with the basics, beyond just swapping the elements, what are we actually looking at here?
Yeah, what makes them tick?
Well, think of them as sort of a cousin to the lithium-ion batteries we all know. The fundamental principle is similar. You've got ions moving back and forth between electrodes when you charge and discharge.
Okay.
But the thing is, sodium ions are bigger, heavier too, than lithium ions. And that, historically, was the sticking point. It made it tricky to create battery structures that were stable and could hold enough energy.
So not just a plug-and-play replacement then.
Not at all. Scientists have been chipping away at this for, honestly, decades. And what the sources suggest is that we're finally reaching a point where the material science is kind of overcoming those hurdles.
Right, so the R&D is finally paying off.
Yeah.
Once you can effectively use sodium, the advantages,
Hmm.
well, they start to look pretty compelling, according to these sources. The first one that really jumps out is the environment.
Absolutely. The contrast they draw is stark. Lithium extraction, it often uses a lot of water, can impact sensitive areas, and the processing itself needs significant energy.
We hear about that quite a bit.
We do. Now, compare that to sodium. From salt, you get it from seawater, huge underground deposits. The sources describe it as, like, ubiquitous and easily available globally.
Ubiquitous is right. Salt is literally everywhere.
Exactly. So from a raw material standpoint, the environmental footprint just looks fundamentally better.
And that availability,
Mm-hmm.
that ties directly into the next big point. Our sources hammer home the cost and just the sheer amount of it.
Oh, this is the economic kicker. Absolutely.
Yeah.
Lithium, it's relatively scarce, right? Geographically concentrated. Sodium is, well, it's dirt cheap in comparison. And there's just so much of it.
So the price isn't going to be as volatile.
Less likely, yeah. Much less susceptible to those supply chain squeezes or geopolitical games. And the sources really emphasize this. The great abundance and low cost makes sodium ion, and I'm quoting loosely here, a very interesting proposition for mass production.
Especially for things where the battery cost is a huge chunk of the final price tag.
Precisely. Think big-scale, price-sensitive markets.
Okay, so cleaner to source, way more abundant, potentially much cheaper, and the tech hurdles are being cleared. It starts to make sense why there's a push now.
Yeah.
So where is this happening? Where are they actually, leaving the lab?
Well, the sources point very clearly towards China being a major force here, and the main application they highlight might surprise you a bit.
Oh.
Electric scooters.
Really? E-scooters.
Yep. Not just talk, they're actually being deployed in these. It's a huge market, super cost sensitive, and you don't necessarily need the absolute highest energy density like you might for a long-range EV.
That actually makes perfect sense. High volume, price matters most.
It's a great real-world test bed, isn't it?
Exactly. Perfect proving ground, perfect place to scale up the manufacturing.
Okay, scooters make sense, but this is where things get, well, more complicated. The sources shift gears quite dramatically here. They go from materials and markets to geopolitics and resource strategy. They really do zoom out, yeah. And they connect these dots in a way that's, frankly, quite fascinating. They start by setting the scene. The world needs more and more lithium, right? For EVs, for grid storage.
Demand is soaring.
Right. And the supply chain has challenges. It's concentrated. Extraction isn't easy. So securing access to lithium is becoming, a real strategic priority for many countries.
Okay, standard resource competition. But they get more specific.
They do. They bring up a specific example to illustrate this point about strategic resource access. They talk about an agreement between the United States and Ukraine.
Yeah.
And according to the analysis in these sources, this agreement, which they note had support from figures like President Trump, essentially gives the U.S. preferential access to some of Ukraine's critical mineral resources,
Including lithium.
including lithium, yeah, and also rare earth elements, things considered vital for future tech.
And how do the sources frame the significance of that specific agreement?
Well, they describe it as having strong geopolitical and strategic value for the U.S. The explicit goal, as presented in the sources, is to secure these essential raw materials, obviously, but also to reduce reliance on other suppliers.
Like China, perhaps.
Particularly from China, is the phrase used in the source material we reviewed. So it's positioned as a strategic move to lock in access through international partnerships.
Okay, so that's the backdrop. Nations making strategic plays for scarce resources like lithium. Now, fold in what we were just talking about. What if these salt batteries using abundant, cheap sodium really take off?
Right. What if they become widespread? Not just scooters, but maybe grid storage, other applications.
What happens then?
The potential impact, as these sources analyze it, is pretty significant. They argue that widespread adoption could effectively reduce global demand for lithium and other rare minerals. It makes sense, right? If you
Yeah.
have a viable, cheaper alternative using a common material.
Demand for the scarcer, more expensive one naturally drops, or at least grows more slowly.
Exactly. And then comes the ripple effect back to that geopolitical angle we just discussed.
The U.S.-Ukraine agreement.
Yes, this is the really intriguing part of their analysis. If global lithium demand decreases significantly because sodium-ion tech takes a big share of the market,
At that.
then the sources argue this could have an impact also on the geopolitical dynamics linked to Ukrainian mines. Specifically, they suggest it could lessen the strategic value of those particular lithium resources for the United States.
So if lithium isn't quite as critical globally, the urgency or the leverage associated with accessing that specific Ukrainian lithium might decrease.
That's the line of reasoning presented, that it could consequently perhaps lessen some of the political or commercial pressure related to securing that access in Ukraine,
So the conclusion they draw, just to be clear, is that salt batteries becoming mainstream
based on their material abundance.
could potentially ease the dependence, their word, on agreements like the one concerning Ukrainian mines,
Yeah.
and maybe reduce levers of blackmail or geopolitical pressure tied to those resources.
That's the core argument laid out in the sources, yes. It's presented as a potential consequence of this technological shift, a way it could subtly alter strategic calculations.
It's a powerful idea, isn't it? How a change in battery chemistry could echo all the way into international relations.
It really underscores how fundamental choices about materials in our technology can have these, well, sometimes unexpected ripple effects on economics and global strategy. It's not just about a better battery.
Right. And again, just to be crystal clear for everyone listening, we're relaying the analysis and the connections as presented in these sources. We're showing you the picture they paint.
Exactly. It's the perspective offered by this specific set of materials, linking innovation, economics, and international strategy.
So let's pull back and summarize the key takeaways for you from this deep dive. What these sources are telling us is salt batteries, especially sodium-ion, are emerging now because the science has advanced,
Overcoming those key technical challenges.
unlocking these huge potential benefits: better environmental profile, much lower cost, vastly more abundant materials compared to lithium.
And it's not just theory. We're seeing practical mass market uses pop up, like those electric scooters in China, a real foothold.
And then there's a big picture argument from the sources that this shift towards an abundant material like sodium could potentially reshape global resource strategies. It might even impact the dynamics around international agreements focused on scarcer minerals like lithium.
And why does this matter to you? Well, it's a fascinating example of how innovation in, say, material science can intersect with global economics and politics in surprising ways.
Yeah, potentially affecting everything from, I don't know, the price of your next EV or scooter, all the way up to some pretty high-level international strategic thinking.
It really shows how interconnected things are.
It really does. It makes you stop and think, definitely. Our sources highlight this potential disruption moving from scarce lithium to common salt. Could change the game.
Which kind of leaves us with a final thought to chew on.
Go on.
Well, considering how the shift to a simple, abundant material like salt could, as these sources suggest, potentially reshape resource strategies and international dynamics, It makes you wonder, doesn't it? What other, maybe seemingly simple technological advances, perhaps also based on common ubiquitous materials, might be quietly waiting in the wings to change the global landscape in similarly unexpected ways?